Look at this map of every tropical cyclone between 1851 and 2010. It's not just beautiful, but it's also full of little clues about how hurricanes work. First of all, that bright, dense blob over the western Pacific is the most active tropical cyclone region on Earth. And a big reason is simple. This part of the world has this enormous, reliable swath of warm tropical ocean, and warm water is basically hurricane fuel. Now zoom out and look at the overall shape of the tracks. Most storms move west at first, then many of them curve away from the equator and eventually drift back to the east. That's because hurricanes are basically passengers in the atmosphere. In the tropics, they're steered by the prevailing easterly winds, which generally push weather from east to west. But if a hurricane survives long enough to reach the mid-latitudes, the dominant winds flip. Westerlies become more common thanks to the jet stream, and storms often swing back east before falling apart. Next, and here's a really wild one, about 85% of major Atlantic hurricanes track back to this little tiny zone off the coast of West Africa. It's likely the planet's most potent hurricane factory, but that's a topic for another day. Now, I think the most dramatic features on this map are actually where there are no hurricanes. First, take notice to this invisible wall right at the equator. No hurricane ever crosses it, ever. That's because hurricanes need another key ingredient besides warm water, and that's spin. And that spin comes from what's known as the Coriolis effect. On a rotating planet, moving air gets nudged sideways, to the right in the northern hemisphere and to the left in the southern hemisphere. But right at the equator, that sideways push drops to zero. So you can get plenty of thunderstorms there, just not the built-in rotation needed to organize into a big, stable cyclone. And there's a perfect visual for this. NASA captured twin cyclones, Asani and Kareem, forming on opposite ends of the equator at nearly the same time, spinning in opposite directions like mirror images as they diverge. And then what's going on around South America? On the West Coast, a major reason for the absence of tropical cyclones is the Peru current, which carries cool water northward. And in the South Atlantic off Brazil, conditions aren't friendly either, with one big factor being persistent wind shear, which literally tears developing storms apart. Except for that one tiny squiggle down there, that's Hurricane Catarina, which somehow beat the odds back in 2004 and made landfall in Brazil. Anyway, do any of these features interest you enough that you'd like to see us do a deeper dive in a full episode? Let us know in the comments.